Hello, and thank you for joining us for today's webinar, Assess Your Visibility Gaps. Do you know how your network is performing in virtual 2021? Before we dive into today's presentation, I'd like to go over a few housekeeping items. If you have any questions at any point during the event, please submit via the chat window or the Q&A window. We will address your questions throughout the conversation and at the end of the presentation. Also, we will be sending out the recorded version of today's presentation after the event. Please look for an email from the Kentik team to rewatch and share the presentation. Justin, I'll go ahead and turn it over to you.
All right, thanks, Angela. Thank you, everybody, for joining today. My name is Justin Ryburn. I run the Global Pre-Sales Solutions Engineering team here at Kentik. Today, we're going to talk a little bit about how to assess your network for visibility gaps. Here at Kentik, we spend a lot of time talking to customers about network visibility, what we'll define here in a few minutes as network observability, and where customers are finding they have gaps in the way that they manage, monitor, and operate their networks. So, we want to share a few of our findings and our learnings from these conversations, and we'll get to a little bit more of that as we go throughout the presentation today. Oops. So there are three things we hear from customers as we talk to them about their networks and how things are going. And I'm assuming these probably resonate with the audience here too, which is networks are becoming ever more complex. So whether that's the enterprise shift from on-prem workloads in your data center up to having workloads running in the cloud, and the complexity that hybrid cloud and potentially even multi-cloud bring to the way your networks are built and operated, or the current pandemic and folks working from home and having to access applications from home on whatever broadband connectivity they may be on that may or may not be reliable, may not be working for them. There's just a lot of complexities that both enterprise and service provider engineering and networking teams are dealing with. These networks are becoming ever more critical as well, especially, like I said, as we move to a work from home model with the pandemic. The network is critical for people being able to get access to the applications, be able to do their work, to be able to be productive. When the network is down or the network is not performing correctly, the productivity of most of our teams grinds to a halt. And then there's the customers, that kind of fits into the first two buckets, which is the responsibility of the networking teams is to make sure that the customers are having a good user experience, a good quality of experience, whether that's accessing internal applications, that's accessing web applications, whatever it may be. The customer experience is paramount here. And so what we see here at Kentik is that the industry has had observability platforms and observability tools in other layers for some time, but the network's kind of been left out when it comes to this sort of holistic observability concept. And we'll talk a little bit more about what that means as we go forward. Some of the use cases that we hear from our customers that they're looking to solve, some of the call them network observability challenges that our customers are struggling with. The first one here is just the ability to troubleshoot any network. You'll notice on each one of these as we go through it, we have some questions that customers are trying to answer. And this particular one comes down to questions around, is the network the problem, right? For an enterprise network architect, network engineer, it's the age-old problem. The network gets blamed for any type of application problem, but without good observability, how do I know whether it's the network? How do I know whether it's the application that's really introducing this application problem? What's driving our DNS latency? I consider DNS to be kind of the unsung hero of networking. People don't spend a lot of time thinking about it. Quite honestly, don't invest a lot of time and money in architecting it correctly, monitoring it. But when it's not working or when it's working very slowly, you can have huge application latency impacts because people don't go to IP addresses. They go to URLs, right? They go to the names of the application. So when your DNS resolution isn't working or isn't working effectively, in all essence, for the customer's user experience, it's not working. So the third one is, why is our application slow? So, again, back to the is it the network? Is it the application? Is there a performance issue on the path? That could be things like latency, could be packet loss, could be capacity of a link where a link is overutilized, that's causing network congestion problems, that's causing the application to be slow, or it could just be that the application itself is slow and the network is running fine. And so having an observability platform that allows people to really peel back the layers of that onion and dive deep into the data and what it's showing them makes these questions much easier and much faster to answer. And you'll see us talk about MTTI, which stands for mean time to innocence, right? How do I take that from hours of troubleshooting and try and figure out my network problems down to being able to see it within seconds that what the problem is, if there is one related to the network. DDoS is another one. Pretty much every day we see a new news article about some denial of service attack against somebody, or some application that's been taken down, or some enterprise that's been taken down because they were under an attack. So one aspect of a good observability posture for a company is being able to answer these type of questions like, are we being attacked? Are we currently under an attack? Is our mitigation strategy working? So can I see the attacks and can I see them being mitigated and make sure that my mitigation of these attacks is effective and is actually blocking the attack traffic while allowing the legitimate good traffic through to my applications, to my users. And then tracing it back. Who's doing the attack and what is the impact on the infrastructure? Can I, if I'm an enterprise, can I work with my service provider to give them the parameters of the attack and have them block it in their network so that it's not filling up my internet circuits that I pay for them? Or if I'm a service provider working with my peers or my transit providers to try and block the network, the attack closer to the source wherever possible. But all of this requires good visibility into the parameters of the attack. Where is it coming from? What is it? What is the volume of it? What kind of ports and protocols is it coming in on? And then the ability to launch from that into signaling a mitigation of some sort. Managing the edge. So this is equally important for enterprises as it is for service provider, although we'll talk a little, probably more in the terms of service providers, where they think of things like, where am I peering? Where am I transiting? Where am I paying for transit? How do I reduce the cost of the way I've built out the network? You see the three questions here, which is, what's our least cost traffic route that we could have this traffic flowing across? Who are my potential peers that I could be peering with that maybe I'm not today? Which kind of feeds into what is my network egress cost. So if I'm paying for transit from one provider, but I could go and get free peering from another provider and reduce the volume of traffic that I'm sending out a transit link, that affects the overall cost to run my network. But we also have enterprises, especially our larger global enterprises, that have very similar pain points when they build and operate a network. So they have a network edge that they're managing and monitoring as well. It's probably more for delivering an application or delivering content across versus selling it as an actual service. But they answer very similar questions and have very similar needs when it comes to observing the network and being able to see where my traffic's coming from and where it's going to, where there are inefficiencies that I might be able to resolve to have a better user experience, to have lower cost for providing the network capacity. Managing a digital experience. So, we touched on this a little bit, but I'll go into a little bit more detail, trying to figure out how is our application performing? What does the user's experience look like when they come to the application that we may be hosting? What is our latency in the east? So for companies who operate multiple data centers or have multiple cloud regions where they're serving an application out of, it may very well be possible that users who are accessing that application from the West Coast of the United States, for example, are having a great quality of experience. But then when people come from the East Coast and access that application, their latency or their performance, their latency is much higher, their performance is much lower when they're accessing that application. And how do we detect those type of regional performance issues with the applications that we're serving up? Is our CDN working? So we have a lot of companies that provide content, provide their own CDN services as either a business or part of as a business where they sell it, or as a product that they offer because they're a content delivery company, and monitoring those and making sure that across the globe, no matter where the users are accessing that content, they're getting a good user experience. How do we figure out whether that's happening or not? How do we set thresholds and get notified when we have a threshold crossing where customers are no longer getting a good experience? So I will take a break there. We got a quick poll question here for folks. So if you'll go out to www.minty.com and use this code you see here at the top of the screen, which is 6661389, you can answer this question, which is, what are you currently using to monitor and troubleshoot your network? So what kind of tools do you currently have in your environment that are helping you monitor your network, troubleshoot your network, some of the things we just talked about on some of these previous slides. So I think let me refresh here, see if we've got any answers in. We got a few answers in here. So I'll give a minute for answers to roll in here. Let me refresh this. See, you got cool. So it seems like a little of everything, but the winner here seems to be network management from an infrastructure vendor. So products that hardware manufacturers like router switches, firewalls, they obviously have network management products that they offer to manage those products. It seems like that's by and large the majority of what people are using, with some others being mixed in with synthetic monitoring and products from security vendors, SIEMs and things like that, I would imagine fall into that bucket. All right. So what does good network observability require? We'll spend a few minutes over the next few slides on this. One of the things that it requires is being able to monitor different networks. We talked at the top of the presentation about how complex networks are becoming. So we have our own on-prem data centers. We have cloud infrastructure. We have SD-WAN. We have our internet connectivity. We may have bare metal infrastructure. We may have containerized applications. We have a lot of different complexities of the network, and I need to be able to see how things are performing no matter which network we're talking about, whether it's on-prem, whether it's cloud, whether it's a WAN or an SD-WAN, whether it's a service provider network, or enterprise network. We need full visibility into all of this across multiple telemetry types, multiple data sources. And then I need to be able to, what we call here at Kentik, enrich that data. And what I mean by that is provide some context to it. So I don't want to just log into a product and see ports and IP addresses and protocols that don't mean anything to me, especially as my infrastructure becomes ephemeral and I've got applications that are coming and going and maybe reusing IPs and ports. I need some sort of correlation back to the name of an application or the name of the content provider if it's a CDN traffic, or the name of the users if I'm looking at my WAN and trying to figure out what my user traffic is. I need to be able to correlate those network premises with information that I can understand, and information that I think of in terms of whether it's the application, the users, whatever it may be. And then there's a lot of different ways we can consume this data. So whether that's building dashboards for monitoring things, that's getting proactive alerts and insights when there's threshold crossings, there's changes in traffic patterns in the environment, being able to apply some mathematical algorithms, what I think these days we're calling machine learning or artificial intelligence, to see when there's correlation between different changes in the network environment, get proactively notified about those. That's a powerful way to use network observability. And then there's integrations with third-party platforms. So these could be things like notifications, messaging with email and PagerDuty and Slack, and SMS messages, getting notified when there's one of these alerts or insights that I talked about that's taking place in the network, being able to automatically generate tickets. There's a lot of different ways that we can integrate with other systems in the environment to make sure that we're getting notified when things are changing, and that we have more of an automated approach to how we're running and managing our network. I touched on this a little bit, but we'll go into more detail. One of the things that you really need in order to be able to do good network observability is think about a variety of telemetry data types. So you've got traffic telemetry. Historically, at least me being a network operator, I think of this as things like SFlow, IPFix, NetFlow, one of those kind of flow protocols that gives me the details of the network traffic in my physical infrastructure. But increasingly, we see as customers are migrating to the cloud, each one of the public cloud providers has traffic telemetry as well. And maybe now in a log format, in a JSON or a CSV file format, but it's giving you very similar pieces of data, which is how much traffic do I have and what's the source and destination, ports and protocols of it, and so forth. So you need that. Device telemetry, so things like CPU and memory, so interface errors, buffer depth, all kinds of different pieces of device telemetry that we can get off the router, whether that's sort of the, I won't call it legacy because it's still the vast majority of what we're doing, but SNMP protocol. And then now as people are starting to adopt some of these new streaming telemetry protocols like GNMI, how do we get telemetry off of these devices and correlate that with the traffic telemetry? We add in things like events. Did an interface go down? Did a route flap? Did an entire router reboot? What kind of events are taking place in the network, which are affecting the traffic in the network? Synthetics. So this is an area that we've seen a lot of excitement in, over the last few years, is how do we measure the paths that our users are taking that are critical to the operation of our network. Traffic telemetry gives you a lot of great information about the volume of traffic you have on the network, but one of the things that it typically doesn't give you is things like packet loss, latency, jitter, like what are the performance metrics of the network, and having intel into those pieces of data is critical for understanding how the network's actually performing. Adding in routing information. So as we looked at the network edge use case, being able to overlay the BGP control plane or the routing protocol control plane that we have with the traffic to be able to figure out where is my traffic going, what are all these paths that it's taking, where is it going out on the internet, what paths is it taking, be able to overlay that is critical for holistic network observability. Adding in configuration data. So this could be things like, did I have a configuration change that's the event that caused network traffic to shift from one path to another, or caused an increase in packet loss because now I have a link that's overutilized because of a configuration change. So being able to pull in configuration data and be able to see what the effects of configuration change on network elements may have on the network performance. Business data and application data, I'll kind of cover these both. We talked a little bit about this, but being able to enrich these data sources with what are the parameters of my business. Maybe this is what IP addresses have I assigned to certain BUs within my enterprise. Could be the subscriber to IP mapping, so I know what subscribers traffic looks like regardless of what the underlying IP address is they're using at any given period of time. Same thing for applications, being able to map the name of an application to the network primitives that is going to be in this network traffic and this device telemetry, and be able to look at on a per application basis, what's the performance, what's the volume of traffic, and where's it coming from, and where's it going to. So tools everywhere. You can tell by looking at this picture, this is a big screen in a large service provider's network operations center. And they've got a whole wall of network telemetry tools of one sort or another. Some of these are probably running pings and trace routes. Some of these are probably looking at SNMP metrics. Some of these are probably looking at SNMP traps, looking for things like events. Some of these are likely looking at syslog events. That could be looking at security events and a SIEM of some sort that looks at firewall events. There's all kinds of tools that exist, and we've had them in our network for years. The problem is when these tools are siloed like this, it's very difficult to figure out the correlation between one network event and the effect that that's actually having on user experience, on application performance, on the things that people are actually calling us to complain about. How do we figure out which one of these network events is what's actually driving the complaint that we're getting from a user? We talked a little bit about this, but I'll go into a little bit more details in order to be able to do this, answer any questions, right? To be able to get true network observability in the way that we define it here at Kentik, you need to be able to get all these various different types of data, right? We talked about some of the network telemetry data a couple slides ago that you need to be able to collect, but you need to be able to get all those into a single platform. You need to be able to get the network primitives. You need to be able to do the data enrichment. You need to be able to have large enough volume of storage so that you don't have to do any type of map reduction or something where you have to roll up the data into aggregates, because that leaves you blind when you get ready to do real-time troubleshooting and try and peel back the layers of onion. You don't want to have to deal with a platform where you have to predefine in advance what it is you want to be able to look at, because how do you know today what you're going to want to be able to look at a week from now or a month from now when you have a network incident? So you want to be able to, within reason, store as all of the data that's being generated by all of these devices and all of these applications in the network, so that when it comes time to do troubleshooting, you have all the data and can really dive into it and peel the layers of the onion back. And when it comes to looking at data, you need a platform that's responsive enough that you can get immediate query results. So you're not spending time waiting for results to your questions to come back. You need immediate answers to questions so that you can troubleshoot much faster. Multi-tenancy is a big one. We have a lot of customers who want to be able to provide network observability not only to their network engineering teams and network operations teams, they may want to provide it to application owners. So they, if they're a service provider, they may want to provide this as a managed service to some of the customers whose networks they manage for them, so that those people can see how their network is running. There are a lot of our educational networks that operate for a state here in the U.S. or a country in foreign countries, want to be able to provide their members, the people who are interconnecting with their education network, visibility into the traffic on their education network. So being able to provide a pane of glass, if you will, or visibility into the network traffic on your own network to your end users is something that's very powerful. Streaming analytics. Again, we talked a little bit about being able to get streaming data into the platform quickly and in real time. Is something that you need to be able to do in order to have good observability. And then APIs and integrations. As much as you can do all of what we've talked about here and getting as much data as possible into a single place, into a single platform, there's always going to be things, as you look on this right slide, that you want to be able to integrate. This may be because you have other tools that you use for certain purposes. You want this data in, or you want to be able to do some automations where when your observability platform finds a network performance issue, it can automatically change routing policies or change security policies or whatever that may be. So having a platform that's built with APIs and integrations built in from the ground up is very critical to being able to solve these type of problems. We talked about a few of the questions that our customers are trying to answer when they think of this network observability. I want to be able to ask any question. Well, what are some of those type of questions? So things like, is the network the problem? Are we currently under attack? Are we being rate limited? So if I'm, if an enterprise and maybe I'm buying sub-rate circuits from my service provider, are those circuits being rate limited? Are they abiding by the contract that I'm paying them for, or am I being rate limited before I hit the capacity that I'm actually paying for? What applications and users are flooding the network? So if I have congestion on particular links, how do I figure out what application is consuming that bandwidth, or which of my users are consuming the available bandwidth? Is SASE performance okay? So if I'm using one of these new distributed security platforms, what is my performance across their distributed network through their cloud security appliances? Am I getting good performance? Are my users getting good performance across those? What devices are failing? So do I have interfaces or entire devices in my network that have failed, that have gone down, or that are just starting to have, maybe they haven't had a hard failure, but they're just starting to have errors. So we're starting to see packet loss or drop packets because we're starting to see a failure. So how do I answer these questions so that I can know what's going on with the network, so I can run the network efficiently? All right. Next poll that we'll ask here. So if you go out to minty.com and use this same code 6661389, the next question is, how prepared are you for network observability? So if you think about things that I've been talking about what's required for good network observability, whether that's the ability to see certain networks, to get certain telemetry types, how prepared do you think you and your organization are for doing these type of things? So I'll give a moment for folks to go out and put their answers in here, and we'll see what we get for results. All right, got 4 answers so far. Let's do one more time. All right, so looks like there's a little bit of most of them, but the overwhelming majority is our tools are good, but we need to upgrade skill sets and provide training to staff. So that's another aspect, is making these tools easy to use so that people can quickly understand what it is they're looking at, that they can quickly get value out of these products and be able to leverage the data and the information that's in there in an effective way to be able to do their job more effectively, whether that's troubleshooting user complaints or application performance issues, whatever that may be. So Kentik is running a network assessment readiness. So, everything we talked about here, if you saw that last poll question, you thought about, how prepared am I for the ability to do true network observability? Do I have the right tools in place? Do I have the right training of my team in place? If you're not quite sure what the answer to that question is, we're running a free assessment that you can go out to this link, run through and answer some questions, and we can give you some advice on where you might be strong, where you may have some room for improvement in your network observability approach as we head further into 2021 here. So, Angela, I think I'll turn it over to you. If there are any questions, we can answer those.
Yeah, thank you, Justin. So we did have a few questions come in. The first one is, what type of integrations do you recommend to improve observability?
So integrations kind of fall in 2 categories in my mind. So the first is additional data that can be put into the product to better enrich the data, right? So this kind of comes back to things we were talking about business context or application context, things that provide enrichment to the data to make sense of the data. One example that we have kind of built into the Kentik product that customers find really useful is IP reputation data. So being able to get a feed from a security company that maintains an IP reputation data and feed that in, so then I can build a dashboard, or I can build views and set thresholds that show me when I have traffic in my network that's talking to known compromised hosts, or from known compromised hosts out to the internet, things like that. And then the other kind of thing that I think of when I think of integrations is, what do I do with the data once I find issues? So whether that's notification channels, that's triggering mitigation appliances or mitigation services, being able to do closed loop automation, like I mentioned. So maybe something I want to be able to do is, when I see capacity on a link or I see latency on a link, be able to adjust my routing automatically based on that, or to flip over to a backup path or a backup circuit that I may have available to me. So there's a lot of different sort of reactions that we can take to changes in the network environment by doing a lot of these integrations.
Okay, thank you. And then we have one more, if you just give me 1 second. So, how can I troubleshoot my VPN user's experience? And then a part of that same question was, we have performance sensitive application traffic over SD-WAN. Can we use Kentik to monitor SD-WAN performance?
Yeah, sure. So the way most of our customers monitor the VPN performance is one of 2 ways. monitoring the edge circuit capacity and utilization. So looking at the traffic telemetry information to say, you know, how many incoming circuits do my VPN concentrators do I have? What's the current capacity on those? And then we also have the ability to overlay that with synthetics. So you can run synthetic tests from various places on the internet or from customers' in user devices to be able to say what is the latency loss jitter that my users have getting to my VPN endpoints. So if we have performance, and it also gives you the path information, by the way, too. So it's not just end to end, but it'll also show you all the hops in the middle. So if there's a particular hop in the middle that's the cause of the issue of the performance on that, you can see what hop it is that's causing that type of issue. Yes, that is something that we do within the Kentik product today.
Okay, great. I think that wraps up our questions. And thank you, Justin, for your presentation today. Like Justin mentioned, you can get your free Kentik Network Visibility Report. And I pasted in the link in the chat there for you to access it. If you have any other questions, please contact us at webinars@kentik.com. And stay tuned for the recording of today's presentation, which we will send out in the next couple of days. So look for an email from us, from someone from the Kentik team. Thank you for joining us today and have a good day. Talk to you later.